Group 7 elements, the halogens. In this section, you will learn about the physical and chemical properties, that means reactions of group 7 elements. They are also called the halogens. I also predict the properties of group 7 elements using the periodic table. Now, group 7 is in the column number 7, just before the last column, which is noble gas. And they are the fluorine, chlorine, bromine, iodine, and astatine. They are all non-metals because they are on the right side of the staircase. They react with metals to form salts. They are non-metals, so when they combine metal, they form actually ionic compound, they form salts. And they are known as halogens. Very important to remember, the name is called halogens. Halogens are the elements. Once they form ions, it's called halides. Ion is called halide. A-L-I-D-S, halides. So they have 7 valence electron. And 7 valence electron means they must be in group 7. So the physical property. So let's look at the color and the states they are in. Now, chlorine is the green-yellow. Bromine is a reddish-brown liquid. And the iodine is a black solid. So note the color and the physical state. Gas, liquid, and a solid. Now, generally, halogens all have low melting boiling points. And they're all colored elements. Okay, they are all colored and they have low melting boiling point. So remember the colors of the elements. For example, fluorine is pure yellow, chlorine is green yellow, bromine is red brown, and iodine is black. Now, going down the group, the melting boiling point increases down the group. Okay, increases down the group. We see from negative to become positive. So it increases down the group. And the color intensity, that means how dark the color is, also increases down the group. So I can say the color becomes darker as you go down the group. So let's predict the melting boiling point of astatine and maybe even the color. So you see the melting point of iodine is 114. So down here definitely astatine must be higher. How much higher? I don't know, maybe 200? Okay, or even 300. Yes, 300. And the boiling point must be more than 184, right? And of course, it must be higher than the melting point, above the 300 melting point. So it's 337, and the state is a black solid. So definitely this temperature, the boiling point must be higher than the melting point. So if you say melting point 250, yeah, I can predict that. Then boiling point can predict 300. So anyway, the prediction is not a very precise value. As long as it's reasonable and is within a certain range, is acceptable. So let's look at this. Chlorine is a gas, bromine is a liquid, and therefore, of course, look at the density is very different. Gas density is very small. Okay, usually very small density for gases. Okay, then let's predict what fluorine is like. Now we know fluorine is above chlorine, above. So definitely it's smaller than this value. Okay, it goes higher, it's smaller. So it cannot be this, cannot be this. Now, how about the melting point? Melting point, it cannot be higher than this, right? It must be lower than this. Okay, so anyway, all are very low. And by the way, since you choose only this is possible, this is possible, look at the physical state. This is a gas. Alright, so anything above the melting boiling point must be even lower. Okay, because it increases down, so going up must be lower. So of course it must be a gas. Alright, so it must be a gas. In other words, answer is A, it must be a gas. Alright, let's look at chemical property. Okay, let's recap. Chemical property is determined by what? Chemical property is determined by what? Chemical property is determined by the valence electrons. Here, look at this. Last number is valence electron. Don't say last number, just say valence electrons. Alright? So you have 7 electrons in a valence shell, so you have 7 valence electrons. So there's a high tendency, means likely to attract one more electron to become stable. So you take in one more, become 8, take in one more, become 8. They all similarly take one more to become 8. Alright, don't worry about this 18 here, it doesn't matter, okay? You don't study too much detail about the third shell, so just assume that, you know, based on the last number here, group 7 must be all 7. And this electron can either be transferred in or can be shared. So if you combine with a metal, of course metal give you electron, it transfer in. But if you combine with a non-metal, it's actually shared. So by itself, it actually forms diatomic molecules. For example, fluorine will combine with itself to form F2, chlorine combine with itself to form Cl2, and so on. Diatomic molecules. Now it's very important to take note of this, okay? A lot of people have forgotten that chlorine is a chlorine gas, Cl2. Even like oxygen gas, hydrogen gas, all the gases are O2, H2, and so on. Diatomic molecules. Now this is important. Halogens react with metal to form halide. Halide are ions. Ions of the halogen, halide. So metal plus halogen, okay, very reactive, they form the compound, metal compound. I will not say this is a metal, this is a salt. Okay, this is a salt. Potassium plus chlorine form potassium chloride, and so on. Okay, this is very important reaction, okay? Put a star here. More reactive halogen displaces a less reactive halogen from its halide. This is very critically important. Alright? So for example, halogen displaces this bromine from the bromide to form sodium chloride and bromine. So how do I say? I say that chlorine is a more reactive than bromine. So I say chlorine more reactive than bromine. Therefore, it displaces bromine from sodium bromide to form the products, sodium chloride and aqueous bromine. I know this is quite a mouthful, but if you remember this sentence structure, it will help you a lot when answering question. So a more reactive halogen like chlorine will displace bromine. How about bromine and iodine? Bromine is also above iodine, so therefore, yes, okay, it will react. So bromine is being more reactive than iodine. It will displace iodine from the potassium iodide. How about this? Bromine and chlorine. You must know the group 7. You don't remember, look at periodic table. F, Cl, Br, I, and At. This in the periodic table. Now Br is here. It's below Cl. Cl is above. So do you think there's any reaction? It only react if Br is above Cl. Okay, you can only displace someone when you're more reactive, must be above. So no reaction. Why no reaction? Okay, why is there no reaction, no displacement reaction here? Because bromine is less reactive than chlorine. So if it's less reactive because it's lower, look at this periodic table. Chlorine is here, chlorine, and bromine is here. So chlorine is more reactive than bromine. So therefore bromine cannot displace chlorine because it's less reactive. So a less reactive halogen cannot displace a more reactive halogen from its halide solution. So going down the group, reactivity decreases. Alright. Now this one is not very important, but if you want to know, the reason is very simple. Group 7 reacts by taking in electron. So reactivity decreases down. Most reactive on top, this reactive below, because as the atom size increases, more difficult for the nucleus to get in one extra electron, to pull in one extra electron. Okay, don't need to know too much detail. Okay, which of the following statement regarding concerning the group 7 element is correct? Okay, are they all gases? No, only two gases, 2 gas, 1 liquid, and then 2 solid below. Okay, high melting boiling point, of course, is wrong. More reactive down, of course, is wrong because it's less reactive down. So of course, answer is they actually form diatomic molecules. Next one. Which statement of astatine is correct? Where is astatine? It's the lowest in group 7, the lowest. So more reactive than chlorine? Of course not. A gas? Of course not, because it's going to be a gas. That means fluorine, chlorine are gases, and a liquid for bromine, and iodine and astatine are I2 and At2 are solid. Okay, so it's not a gas. Now, very soluble in water? No, they are not very soluble in water. Covalent molecules generally are not soluble in water. So the only thing is what? They can react with metal to form a compound. Remember, we talked about halogens can react with metals. So this is new element OH. OH with 7 valence electron. Where must it be? It must be in group 7. So what can I tell about group 7? I cannot say that they must be solid liquid. I do not know how big this particle is. Form ionic compound with oxygen Now, oxygen is a non-metal. Non-metal, this group 7 is also group 7, right? Group 7 VII is also a non-metal. Non-metal and non-metal cannot form ionic compound, and non-metal cannot form positive ion. So the only answer is group 7 diatomic. So you realize that this question comes up very often. You must know that group 7 are diatomic molecules. Now this one, this is a displacement reaction. Whenever you see a halogen and then a halide, look for displacement reaction. Okay, it only happens when the one that goes in is more reactive than the one that's inside the solution. So obviously, answer is reddish brown observed because aqueous bromine will form. So therefore, it's reddish brown. And of course, indicator down here color is different. This will be bleach because chlorine is bleaching, and chlorine water has no visible color, very pale yellow. You can hardly see the color. Group 0 elements, the noble gas. We don't study much about noble gas. We just need to know that they are unreactive. And then why are they unreactive? They are unreactive. Lack of reactivity is because of the electronic structure. Now, what is the group 0 element? It's the last column, right hand side last column. And these are the noble gas. Okay, they're all non-metals and they're called noble gas or inert gases. Now, they are inert. Last time we call it inert gases because they are not reactive. However, it doesn't mean that every single one of them will not react. They may react under very special circumstances, especially those at the bottom, but it's not in the syllabus to know that they will react. Alright, they react under very special conditions, but generally they do not react. So the name given to them should be noble gas. Okay, be more accurate. Now, physical properties: colorless, odorless, no smell, no color, you can't even detect them. Very low melting boiling point, they're all gases, and they're insoluble in water. Alright, these are the physical property you must know. Now, what are they used for? Okay, they are unreactive, right? Mostly unreactive. I would say generally unreactive. So they provide inert atmosphere for the tungsten light bulb, for argon. Argon is used in light bulb. Take note of that. Okay, neon is used to make neon lights, advertising lights. Okay, so you look at the configuration here. The first shell is 2, means it's completely filled shell. Second shell is 8. Okay, these are completely filled shell. Sometimes they call them duplet configuration or octet. Octet means 8. Duplet means 2. Alright, these are completely filled shell. So they have stable electronic structures. And stable electronic structure also means that they're completely filled shell. So therefore they are unreactive. They do not need to gain, lose or share, and they do not form compounds. And hence, they exist as a monatomic gases. Monatomic means monoatomic. Okay, a single atom. Alright, so neon in group 0 has electronic structure of 2,8. Explain why neon and the rest of the group 0 members, the noble gas, are unreactive. Now this is a very important question. They have fully filled valence shells and hence stable. Answer is fully filled valence shell and therefore they are stable. Alright, please remember this answer.